We've talked about the segment addition theorem, so let's talk about how midpoints can be used to find the lengths of segments and look at some examples. So here let's begin with some definitions. The midpoint. What is a midpoint? The M-I-D-P-O-I-N-T, midpoint of a segment is a point that divides the segment into two congruent, and remember that congruent means the same, two congruent segments. So the midpoint splits it into two even pieces. Right over here we can see that B is the midpoint of AC. It splits it into two equal sizes. A line, array, or segment that intersects a segment at its midpoint is said to bisect or cut in half the segment, and is called the segment bisector because it bisects the segment, called the segment bisector. So in the diagram to the left here, B is the midpoint of line AC. So we can see that segment AC here has a midpoint of B. And line L, and we'll use the cursive L there to represent this little guy down here, this is L, is a segment bisector of AC. So in this case, the bisector is this line right here, line B. So how exactly does that help us? Well, if you look at this, this looks very similar to what we had when we did segment addition postulate, right? We have two segments together. Here's segment PR, right? So that's segment PR, and it's broken down into two pieces, segment PQ and segment QR. And we learned that the segment addition theorem says that I can take PQ and add it to QR, QR, those distances there, and I add them together, and that will give me PR. Now what the midpoint allows us to do is say, well, if this is in the middle, if point Q is the middle, then I know that 7x minus 16, or PQ, the distance from P to Q, the length PQ, is the same as the length of QR. So these two things are equal to each other. And whenever we're finding the value of a variable, we need to have something that's equal to something else. So I can say that 7x minus 16 is equal to 4x plus 2. Now you can see pretty quickly that we can solve this kind of a problem. We've dealt with these before. We're going to get our variables on one side and our constants on the other. I'm going to subtract 4x here. So subtract 4x. These will cancel, leaving me with a 2 on that side. And over here we'll have 3x minus 16. We'll add 16 to both sides, right? These are just common things that we do for algebra. So we add 16 to both sides. We get 3x is equal to 18. We divide on both sides by 3. And we get that x is equal to 6. That means if we want to find the length of PQ, right? PQ is equal to 7 times whatever x is, right? So 7x minus 16. So we'll take 7 and multiply it by the 6 and subtract 16 from it. So that's 42 minus. And 42 minus 16 is going to be 24 there. 26. And likewise, if we wanted to find the measure of QR here, then we can say, there we go, the length of QR is equal to 4x plus 2. And x, I know, is equal to 6, so 4 times 6 plus 2, that's 24 plus 2, so QR is equal to 26. Now you'll notice, again, these are supposed to be, Q is supposed to be the midpoint. That would make both of these equal, and in fact, it is true that they both are because we can see that 26 is the length of PQ, and 26 is the length of QR.